Howdy Hacksters! Today in the studio, well, in their studio, we have Joshua Zimmerman of Brown Dog Gadgets. Hey Joshua, what's up?
Not much. Yourself?
I don't believe that, but I'm doing well over here. This is really exciting. I've wanted to get Brown Dog Gadgets, you specifically, on here for ages. Can you tell us about your company and what you do?
Sure. Also, Pete, my wonderful maker guy Pete, is over here to my left off screen doing things. To hear another disembodied voice, it's Pete doing things. Oh, and also doing sound effects too, apparently, in the background. Thank you, Pete. You're wonderful. Anyway, so Brown Dog Gadgets, we do STEM education products, lots of arts and crafts make and takes is kind of what we're known for, low cost, fun, hands-on STEM craft activities. We also do a lot of fun programming things with Arduino and Microbit, and combining that with Lego to do fun circuitry, circuit boards in a Lego environment. So we do a wide range of crazy, weird stuff all the time. And yeah, we love showing it off and dealing with teachers, librarians, summer camps. Been doing this about 8 years now, full time. There's 5 of us here full time now in our warehouse and office, and it's pretty darn fun.
Oh, yeah, I bet. Well, we have your Twitter page up, but you also have
Ooh.
previous coverage of your technology on Hackster. We got to play around with these Lego robot kits, which is so cool. I've done a little papercraft companion robot with your stuff, and we love it. So you might have seen Brown Dog Gadgets previously on the channel, but from what I understand, you have a ton of new stuff that we haven't even seen before. Why don't you tell us about that?
So we have been doing a lot of Microbit stuff. In the past, we did Arduino stuff galore, and our Lego Crazy Circuits Lego format. It's our modular electronic system, all 100% open source, all Lego compatible, so that people can make fun circuitry on Lego. Did a lot of Arduino stuff in the past, and we end of last year we switched to, or added into the mix, Microbit, as well as Adafruit Clue, since it uses the same connection format as Microbit. We just do some Clue stuff.
Right.
And so we've been making up tons and tons of projects for Microbit, including curriculum, which our curriculum writer Andy has just finally finalized here not that long ago, for a whole Microbit like 2-week plus curriculum of how to do Microbit programming and fun stuff. So Pete and the rest of us has been doing tons and tons and tons of Microbit related projects galore this past 6 months, all sorts of weird stuff. And I guess our philosophy around here has been the Microbit's fun, but it's often overlooked for its more advanced capabilities. It's got a lot of power behind it, but the way it's marketed and sold towards most schools is a very beginner product, which it's great at doing that. However, there's all these other cool stuff you can do with it that people kind of forget about. So we've been taking a lot of the, kind of joking, taking a lot of the medium level Arduino projects people doing for years and making them into a nice Microbit format with great directions for teachers, especially newbies, librarians, teachers, students. Like here, you want to make a simple robotic hand demo with a Microbit. Here's how you do that. You want to make a xylophone that plays music with servos. Here's how you do that with Microbit. And so we put a lot of fun stuff out there that's interesting that just hasn't really been done in the Microbit format before, although it is stuff that has kind of existed out there for a while in one form or another.
Yeah, because you do have the 5 big pins that people tend to see with the beginner stuff, but then of course you actually have tons more pins that are visible in between those, and you can't really access those without either soldering to the board or using a breakout or something. So are you using that?
Yes, so we have our adapter board, we call it the bit board. It is just your classic breakout pin board for that, to our Lego format, as well as 2 pin headers, so you can plug in servos and sensors. Simple sensors, I love simple sensors with Microbit. Like a 7-segment display, a thumbstick are great tools to use. They're so simple to use too in the Microsoft MakeCode format as well. But that's how we access all those extra pins on there. And even bringing things like OLED screens is really, really, really easy to do in the Microbit format. And OLED is so fun, especially for kids. Like, oh, I can do some fun displays and text and whatnot on there. So yeah, it's got a lot behind it that people just don't realize they have available to them, because it's marketing. And I gotta say, they really do a great job of helping out those beginning students and teachers. And I've worked with so many teachers for the past 8 years who an Arduino is such a learning curve for them. It shuts them down instantly. But the Microbit is a great format just because they really handhold your way in and coax those anxious or hesitant new users into that system, not realizing that it is so darn powerful and they can do so much more with it than what they first start out thinking they can do.
Oh yeah, and even the programming environments, you can do the drag and drop block code programming, but then also you can translate that to JavaScript, to Python, and like toggle between them, which I think is such a powerful way for transitioning people into more complex electronics and software from this basic kit, like you're saying with the hardware. So we've got this bitboard kit here.
There it is, the second picture down. That's our bit board. It is very much like all of our other, like our robotics board, just an Arduino breakout board. And you've got the Lego holes around the outside that we use our nylon conductive tape to then make literal circuit boards on Lego, which I love from a teaching perspective, because the kids or adults have to make quote unquote real circuits the way you would on a real circuit board in this Lego format. And that's right there, that picture there is a great example of wiring up a ton of LEDs and buttons in a real to life format, just using Lego instead, which is a great visual format that everyone knows and loves, and everyone's happy with Lego. It's the world's most popular toy for a reason.
It's true, and like you say, it's very visual. Like you can see exactly how the circuit is. Unlike with the circuit board, where you kind of have to squint at it or hold it up to the light, you can totally see what's going on here.
Or a breadboard with jumper
Or a
cables all over.
breadboard.
Nothing
Yeah.
is more like heartbeat increasing in a classroom setting than a breadboard full of wires that should be working that's not, because I've done that in my own classroom back 8-9 years ago when I had a classroom. Like it looks correct to me, but so many little wires going all over the place. This is a great easy visual format to both troubleshoot as well, which is great because you can just walk by like yes, no, nope, backwards, and it's just easy to fix. You want LEDs on backwards, pick up, turn around, put back down again. So it keeps that easy breadboard ease of use, but in a format that's really, really, really straightforward and visual. And also if we're doing like simple circuits too, you can go from a circuit diagram to the circuit on Lego, and you can see that nice visual comparison between the two very easily, which is great for newbies. Yeah.
Totally. And with these Lego boards, the little LED ones, you've got the positive and negative sides highlighted. So when you have an LED stuck into a breadboard, you can't always tell which side is the long leg.
Yep.
And like, it's really hard to see which side is flattened out if they've even done that. So this makes it so visual and obvious. I love it.
We try to have early on came up with a very nice, just very simple format to the way we wanted to have everything laid out visually. And after that, it was just seeing which parts we liked and which parts made the most sense and which were the most useful. We've had our GitHub repo has a bunch of parts and components we designed, and even some of them we prototyped but never put into production because we just didn't think it'd have enough use case for the average audience we have. And only recently have we started producing a potentiometer piece and a NeoPixel component this past year, because suddenly we had enough demand for our stuff. We're like, yay, we have a little extra money. Let's get these into production, start putting them into kits because they're useful. And everyone loves a good NeoPixel or a nice little blue potentiometer knob. Turn that knob, your servo turns, your LED changes color. It's a great feedback. So yeah, we just, whenever we can, we try to like get one more part into production. It's
kind of like Little Bits, but not as expensive and more compatible with other things.
I love Little Bits. It was very simple. They did a great job.
I do too. They're beautiful.
But when I had a classroom of kids, I had Little Bits. I spent way too much of my own money back when I had way, way less. And my students just didn't get how they worked. You hook a couple parts together, like, oh yeah, magnets, that's what's doing it. Little Bits is so easy, it removes the learning from it.
You don't actually see the circuits.
Exactly. I kind of compare it this way. It's like microwaving a food container you got from the store and saying, hey, I learned how to cook. I mean, technically you're cooking food, but it's all okay. First, say making something from scratch. And so that's the two compare. Little Bits is very much the microwave stuff up and look, it's done. But my students lost interest very quickly because it was really easy. And they didn't
like
get
maybe it's a different age group, do you think?
Well, they marketed heavily towards schools. Like they were marketing it to like middle schools and high schools galore. And it just, it was interesting. I liked the idea, but they kind of lost on some of that learning that would come with it. And it's a weird fine line, especially for like middle school kids or beginning high school students. There's a fine line between being too easy and losing their interest. And like Snap Circuits is a great product, but the middle school kids were just like, oh, that's too easy. That's kid stuff. Even though Snap Circuits is great because it is real circuitry hooking together in a real format, but it was too kiddie for the middle school audience, let alone high schoolers. So
that's interesting.
Kids are weird.
So you don't think that Legos make it too kiddie for the older kids?
Yes and no. Lego being just a familiar format makes it easy, but the stuff you're putting on there is what makes it more difficult. And really just Lego's just what you stick the parts onto. The nice thing is too, you can also bring in more complicated things, making 3-dimensional circuits out of Lego. Most of what we do is a 2-dimensional plane, but you can make three-dimensional things that move as well. And you can easily add in gearing. Oh, I have a couple of these to show off. Pete has done a whole bunch of really cool adapters, 3D printed adapters to hook up standard, like off the shelf Arduino sensors onto Lego.
This is so cool.
So even like, yeah, so all those, I actually have a bunch of these on the table.
11 or 22 here.
Yeah, 11. And then my go-to wonderful, my favorite 7-segment display there. I love that. I
use it in too many things. That's really cool.
But I mean, Pete did a great job of just, cranking out a bunch of those for things, even just a simple battery holder. But just, again, making it that format change. And the fact that we're bringing in microbit and Arduino to stuff. Okay, we're doing Arduino projects. It's the same thing you do on a breadboard, just on Lego, so it's a nice grid, and everyone loves a good grid to work off of. I'm a graph paper guy, so
totally.
like, graph paper,
dot grids.
Say the one cool thing about Lego that people never do that we occasionally do in our projects. So we always go over the top of the Lego stud, but you can also go between the Lego studs to make a 2-layer circuit board. So we have sometimes where if you plan things out the right way, just make your common ground between the studs and have things go over the top of it. 2-layer board. And if you want to make a 3-layer board, you just go on the backside of your Lego as well. But yeah, so we've done some really weird, like overly complicated things because you totally can. And we have customers every now and then sends a photo of like some really weird thing they've done. And we're like, that's awesome. Well, shoot, we took a Lego, that's a Lego kit they produced for a short while. It's a little tilt maze. We just added 2 servos to it with a thumbstick to make it kind of silly and automated. And the hard part was the Lego. That's a cool thing. The hard part was the Lego. Electronics was pretty simple on that. So yeah, usually when it comes to Lego things, the big Lego project is a tough thing. Everything electronics wise, it's like, oh, NeoPixels on a big Ferris wheel, or Tron cycles because we could.
So I have a weird question for you. You say Lego all over the place, and from what I'm familiar with, is people being like Lego style bricks or something like that, or like, how do you get away with it?
So Lego, the company, we've got a cease and desist letter once too, and I've talked to several small companies who sell Lego accessories, things that work with Lego. They have a very nice write-up on their website, a great PDF on how you can and cannot use the word Lego and how you can use their logo, and if you're a Lego fan group, even what you can and cannot do. And so usually people say brick compatible or Lego compatible, but there's Rob from Bricklink up in Minneapolis, and I had a long discussion once because he's been back and forth galore with like even things, he calls them like brick something or another, and Lego wants him to cease and desist letter saying, hey, you can't use brick with this.
You can't use brick with it?
Well, in this certain situation, and he went back and forth with them. So I, not being a lawyer, have relied heavily on other companies who do this already, and what how they recommend you do it as a small business to do that. But I know Lego is very protective of its brand, as it should be, and do like to make sure they say that. So we typically all say brick compatible. We do include real Lego pieces in our kits, like official Lego pieces that we purchase and put in there, like our 8x16 green base plates are official Lego parts. But we do like to say brick compatible heavily on a lot of our stuff because I don't want to get in trouble with Lego.
Yeah, I bet they have a lot of power. It's a really interesting part of being a small business. And speaking of the business side, how have you been affected by everything going on in the world today? There's pandemic stuff, there's school disruptions, but there's also like tariffs and things. Let's get into some of that.
Pete's laughing here because he knows tariff rant. No, so first and foremost, since a lot of the stuff we do are small consumables, our paper circuits, our BristleBots, we have a fun solar powered like BristleBot called a Solar Bug.
Love it.
Fun papercraft thing, which we introduced last year because people were asking for something else to do. But distance learning actually was a weird double-edged sword for us. Our sales to all of our education resellers dropped to nothing, and they make up over half of our sales or more in a month. That happened across the board for pretty much any educational library supplier. A couple of library companies I know shut their company down completely because no libraries were open last year. But we did a ton of distance learning custom bags and kits for people. And actually our sales were about the same last year as they were the year before, which was yay, made me very happy to have that happen. This year, education market has been just bonkers because I think everyone saved up money. I think most of our resellers have told us that this is their best year ever. A lot of small companies I talk to, again, our best year ever. A lot of just because there's money to spend, leftover money they didn't spend during COVID, because there no kids in the classroom, no field trips, no new jerseys, no new like there's all this cash they had to spend, but also some government money as well for catching kids up through distance learning this summer. And I kind of have a feeling too, when it comes to a lot of hands-on materials, that either one, the teachers are just really jazzed to have kids working in groups with hands-on stuff that they weren't able to do last year, kind of the stuff that we do, but also getting more of that than they usually do so that you can have smaller groups so you don't have to worry about any chance of spreading contagions. So no, everyone I've talked to, nobody knows why. But we have some pretty good good theories as to why the market's so hot right now. But we still do a lot of teachers and librarians and summer camp programs are buying our kits and then sending out bags of stuff to kids all over their school area, districts, libraries, all that fun stuff. So that's been actually really interesting for us. It's allowed us to do some fun stuff this year, upgrade equipment, buy a new laser cutter that we had extra money. Yeah, we just had some small children in here the other day to do some product photography with. So, we actually have some extra money to spend on things for a change. The one upside to the pandemic, no trade shows, no maker fairs to travel to. So I'm much more well rested than I was like a year ago. Because usually we were heading up to a trade show about once every month and a half. So it was a lot of traveling, a lot of prep work, and I'm really, really not looking forward to going back to doing that again. The only thorn on our side are those tariffs you mentioned. Yeah, just because they continue to jab every small business I know. And to put it this way, so we get all of our parts pretty much made up in China, custom for us, from our conductive tape to even our 10mm LEDs we get custom made. We have built-in resistors on our little 10 mils that nobody sees, but they're really handy for classrooms because,
oh, cool.
Well, your standard teacher doesn't realize you put a red and a blue LED in a parallel circuit on a piece of paper. The red's gonna light up, the blue will, maybe a little bit, but no one realizes that. And you know what? No reason they should. However, building a little resistor in here, make sure that no one has ever to think about it, just works. So we've had people like, hey, why is this working? It shouldn't work. I'm like, built-in resistors that no one else cares about. So we even got our own custom toothbrush head made for our bristlebaits. Yes, we are fancy. We get our own custom toothbrush head made.
What's special about it? Is it just that you don't have to waste the whole rest of the toothbrush?
The number one pain point of bristlebaits is cutting the head off in a classroom setting. Nobody knows what the best tool is. Garden shears, like nice rosebush cutting garden shears. But yeah, it's a nice edge. It works well. It's exactly the toothbrush you want. Because the best toothbrush is the Oral-B cross action. The best one. Unfortunately, they're like $5 each. And Oral-B does not like to wholesale out to STEM companies. So we do things you'd never think of when you go from teaching to doing this. But since we get all these parts done overseas, because really no one will make toothbrush heads for us here in the US, or no one really makes 10mm LEDs here, we're paying tariffs on everything because we do all of our own packaging here, because this one LED is using like 5 different kits. So we package everything up here. Now, as opposed to another company we know, a friend of ours, he has all of his STEM kits made entirely up in China. They come in a container, a shipping container, completely finished. And so he pays no tariffs because it is a finished good. So we're paying tariffs because we do the packaging here. So my kind of sarcastic joke is, it's my mistake for employing people to package things in the US. I should just employ people in China. And then I save money.
Punished for.
Well, it's rough because right now too, the silicon shortage, so to speak, is causing random things to just spike in pricing. So we recently got a quote, actually today, the thing that usually costs about $2 is now going to cost about $4, which also means my tariff price has also doubled as well. So instead of paying 50 cents tariff, I'm paying $1 tariff on this one particular thing out of the blue. So it's really hurting a lot of small companies. And yet we used to get our parts made here in the US, all of our circuit boards down in Chicago from a company. However, moving it to China, even with the tariffs, is still cheaper than having it done in the US for simple stuff. And I've heard that from so many companies that, yeah, the tariff, it bites into things, but even with the tariff, it's cheaper than having it done in the US. And it's one of those, it's a weird thing. So I'm really, really fingers crossed things get smoothed over at some point, because it's hurting a lot of small companies in weird ways, and really punishing people who do the packaging here in the US versus, having us just entirely get things made up in China. We like the flexibility.
It doesn't even necessarily drive that market back to the US. It's like not enough.
Not for a lot of stuff. In my building here, there is a gentleman who has a company that makes a really nice magnetic metal shelf for stoves. That is his business, and he does a ton of it on Amazon. And because of the tariff, they were looking at getting that metal done here, the stainless steel in the US, having things moved over here. But the prices were just astronomical compared to it. It was just double or triple the price for manufacturing. So he's like, no, even with the tariff, it's not worth doing. And that's the weird thing. It's just certain things are great to have done in the US. And unfortunately, China can just beat you out on materials as well. And yeah, it's been really weird. We're lucky because a lot of the stuff we do is pretty darn simple and pretty inexpensive individually to make. But I know a lot of other companies that got really hammered hard by it. And for especially education companies, sometimes the margins are not
Oh,
great.
absolutely. Yeah.
But even for the general maker market, seems to have even thinner margins and price points. It really just makes things so rough.
Understandable.
Even like battery holders, like brand new thing, battery holders. I know DigiKey, they have on there when the columns is there a tariff applied? And when the tariffs first rolled in, you could see that column get more and more full of check marks as they kept switching over their inventory, and their prices just jumped up on random electronic parts, transistors, resistors, all that fun stuff. But yeah, it's been really annoying, that's for sure. And I'm really just fingers crossed something changes on that, because it has not really moved much stuff back to the US, it seems. And yeah, anyway, let's talk about really cool things you can see instead of me. Pete's heard my rant about tariffs way too many times. And Pete, would you switch over that wood and the laser cutter?
I will do that.
Thank you. Sorry, we were trying to get so much laser cutting done lately, and like I got a half an hour, and this thing takes a half an hour to cut, so it works out well. So we got a couple projects to show off. These are things actually Pete has made recently and are new. Let's take a look at these couple of things. I think you'll like these things. So first and foremost, we have what I call Pete's favorite project. This is a cowbell, by the way. This is Pete's automatic cowbell hitter. It's a little servo. These are fun little Lego compatible servos. They're not ours. We get them from KittenBot, actually. They're a Chinese company as well.
They're super cool. They do a lot of microbit robotic stuff, right?
They do. And their little Lego compatible servo is basically perfect for everything we do, because everything's in a Lego environment, and way easier. We used to laser cut our own little adapters for those little standard 9G servos that everyone uses, blue 9G servos, but this is much easier just to pop on and add a couple of Lego, and you have a nice form factor. Again, it's the difference between having to hot glue stuff down and just sticking stuff down, especially in a classroom setting. But this is using an Adafruit Clue on our bit board, but it's just. And at one point, Pete had it set up to automatically hit a cowbell every like half an hour to announce something. But it's just, and unfortunately, I probably can't see it on here, but the little Adafruit Clue has a great little screen on it, OLED screen, but it says, I've got a fever, ... to quote the famous SNL sketch about needing more cowbell.
More cowbell.
It is. And this is just like, sure, why not? It's a Tuesday. Let's do this. But we like showing off stuff with the Adafruit Clue every now and then, because it does have the same pin setup as the microbit. So any microbit accessory is automatically a Clue accessory for breaking things out, which is nice. And the Clue has some really nice, like higher end features as well, like a nice OLED screen, which usually most of the stuff on there is really overkill for most people, but it's got a really amazing, nice set of features on it for the price point. So full disclosure, Adafruit does sell our bitboard kit. So thank you, Adafruit out there. But their Clue has some really fun stuff on there, and it's great that it has in the microbit format. But this is one of the random projects we had on our big tabletop full of projects in the hallway. It's always overflowing over there. So,
that's so rad.
Our next door neighbors in auto body shop are playing very, very loud music from their very custom auto body shop stuff. So if you hear music in the background, it's from that.
Okay, cool.
Pete made up a great robot hand project. Your classic servo straw hand activity, because we had a lot of requests from teachers. How do we do a robot hand, or like a hand-esque project with a microbit? And so this is how you do it. And Pete did a really nice write-up with templates on that, because usually the electronics isn't that tough for hooking up servos, but it's always the mechanics that always throw people off, because something like this takes a little bit of troubleshooting and trial and error to get a format that works well. So, good. So we just have 3 little potentiometers right here. I just turn the potentiometer and it should turn the, you know what's happening? I don't have I should plug into here, not to that. Battery pack, not the USB port. Servos need a little bit more power, but you get the hand movement on here, which is just fun. This is a great demo that's not tough to do. And a lot of the projects that we do, cardboard's a great medium to hook things up to, but getting the servos in place, getting the components in place is nice and easy with Lego, as opposed to trying to get that done by hot glue. I hate using hot glue in a classroom. It is the bane of every teacher's existence because it just leads to burnt fingers and mess. The worst injury in our entire company history was because of hot glue. Every soldering irons, no problem. All this other equipment, no problem. Hot glue gun, oh yeah, more than once we've had like a requiring Band-Aid kind of level injury because you're just hot glue. But the hand is a great thing. Pete has made up a very nice write-up on templates for these on our website, and something I think we'll be posting to other places later on. We had more time this year. But also we hooked up a OLED screen because it shows on that OLED screen the, what is that, the angle of each of those. And this is a prototype. We're doing a minor update to our bit board at some point in the future. We added on the SDA and SCL pins 19 and 20, so you can use something like a OLED screen very easily, as opposed to having to break those out even further. And that's what
C devices.
What is that called?
I2C devices.
I2C. I always say it wrong. I2C devices, and it's just really handy. And OLED screens are so darn cheap these days, and might as well jump in. Those little things that look really fancy, especially for kids, it really helps them get in the spirit of things. And the more fancy you can make it look and feel, the more they get into it, the more they feel that it's a more of an adult project. Even for adults too, they want to feel that they're doing something that's at the appropriate level. It's a weird mental like back and forth, especially that middle school crowd, which I taught at, just because they feel like they should be adults and doing adult level things. However, they lack the skill set and maturity and troubleshooting to actually handle it. So you have to like, okay, fine line. And even in a classroom of 30 kids, you might have, say, a third of your kids that are advanced, a third that are, average, and a third that need a lot of help. And so you have to find activities you can expand on and make sure everyone is getting it, being interested, learning, and really having a little bit of fun so that it stays with them. So yeah, we try to do a lot of weird fun projects like a little robot hand. Pete has made a wide variety of really fun paper knife switches, cardboard knife switches, which we keep telling. Style. So here's another fun one. The game of operation, but microbit, which I had not seen other people do before. So we're like, let's just do this. So what we've done here is your very classic operation game. And we've just made a layer of Lego with our circuitry on there. Even nice little holders here. And then this is just a little template on top. So if you want to change it to say, I don't know, your favorite character from a TV show, or make a less silly robot. But then we use a couple popsicle sticks here with some maker tape on it to, I'm not good at this game, to pick things up. And ages ago back, I guess we looked at 10 years ago. Its 10-year anniversary was like a week ago. I posted on Instructables how to make a gigantic game of operation for back when I was a teacher, 2011. It's still up there. And we're like, oh, it's been 10 years. We're back on the operation thing again. But this is just a fun little game with a microbit, because a microbit, instead of just an analog version, you can have a little bit of extra buzz, extra delay. And the new version of the microbit has a built-in piezo on it. And I think one of the extensions we're eventually going to do with this is make into a more of a game format where it counts down for you. You have like 5 points or 3 or 4 attempts, life, if you will, and just make it a little more game aspect, add a couple other little bells and whistles, so to speak, maybe throw a servo in, but just to expand it out, like here's the simple version, here's a medium version, here's a more difficult version. So if you're in a classroom setting, you can have like, hey, make the base version. And if you happen to have an extra 10 minutes in your time, choose one of the add-ons to do as well. That always that extension to an activity for those kids who, like myself, used to be like, I'm done in 5 minutes. Now I'm bored and causing trouble, which is just, kids in the classroom. Sometimes those kids who get through stuff too quickly, like they cause trouble because they're just bored and they've got through the activity. But this is a fun one. Pete just posted this, last week, was it, Pete?
Yep.
And so, just send microbit on this. And you could just, do this very easily by just alligating clip to a microbit, but we're going to add a few more things like a servo and some other things onto it just to make it a little more expandable. So cool. This is one of the other fun ones that we just recently did. So yay.
Well, congratulations on 10 years.
It's like, I look back at some of the instruction was like, wow, I took such bad photos back then. You can tell, like some of them too, I redid the photos, Pete, like five years ago, I redid them. Even I'm just like, wow, those photos are still bad. You can tell when I tried changing my photo format at one point.
Can I ask you about something really? Oh, sorry.
Oh, go right ahead.
I'd love to ask you about the maker tape really quick. And
sure.
I do want to hear about this project as well. But how do you get something like this manufactured? Because could you tell us what is so special about this? I know we've covered about it before, but it's just such an amazing thing that you've come up with here. And I'd love to hear about how you made it.
Sure. So we were using just standard copper foil tape for a while. That's what everyone used. And still a lot of people do use it because it was readily available as the go-to thing for the maker community as a whole, because it existed in large quantities everywhere at a very cheap price point. However, it always made things difficult for us because we started using it like at maker fairs, especially with younger kids and that really fourth through middle school age range. You notice that kids sometimes have a lot of issues with that copper foil, the fact that it breaks really easily because it's just foil. Or they say, let's say they mess up, like, oh no, I didn't go far enough. I have to add more on. But a lot of well, nowadays it's some better, but it used to be where none of the copper foil tape was conductive on the bottom. So you have to start all
The
over
adhesive
again.
was non-conductive.
Yeah. So it always rubbed us the wrong way because I'd watch in my own classroom, other places, just kids having problems. And I've just been at maker fairs watching other people's booths, like having issues galore. And it turns the kids off. It makes it way more frustrating. And just, if they're frustrated with the project activity, they lose interest, like any of us adults are too. There's a certain amount of frustration put up with before just like, screw it, I'm done with this project. I'm not going to do this anymore. We want to make sure the kids are gaining confidence and having fun. So we got to take that into effect. When we were building up crazy circuits, our first approach was to go to copper foil tape because we had access to it and we had a manufacturer we had found and used for a while. We went to Alibaba and talked to a bunch of different places, Alibaba website, to find copper foil tape ages ago. And just we're like, okay, let's try some different tape. We even tried Lego hole punches down the middle of it. But the problem was copper foil tape is so weak, it would go onto Lego, it wouldn't come off. And so you'd have Lego just was covered with copper foil between things. It was horrific. We're like, no,
nightmare.
We can't do this. And so we ended up talking to our manufacturer saying, hey guys, what other conductive materials do you have? What other things can we use? And they told us, we have fabric tape as well we use for this other things. At that point, I think it was mainly used for like EMF shielding on a lot of stuff. And this was like when like 5 years ago. So just slowly was like conductive fabric coming out too. Like now I can go to Adafruit and buy like a sheet of like conductive fabric, which is fantastic, or conductive zippers or conductive Velcro. But I'm like, okay, this is cool. So we tried out different versions of that and we worked with them to get the adhesive mix right. So it'd be conductive on top and bottom, and even changed up the way when we first got it. Originally, it came with a layer of copper foil. It'd be like the conductive fabric, copper foil, and then adhesive. But we actually found that we could remove that layer of conductive of the copper foil underneath there, which made it cheaper for everybody and actually more flexible too, because it wasn't there anymore and worked just as fine conductive wise. But it took a lot of trial and error. It wasn't expensive. All the things we've done, that was fairly inexpensive to just try things out, work with them on just doing some minor tweaks. And then we just started manufacturing up galore. So we could use it for our different projects. This is 1/8 inch stuff, and the 1/8 inch stuff I can rip by hand as an adult. I can brute force through there, but that 1/4 inch stuff you can't, which is great for kids because they can sit there and they can put it onto fabric. They can make a wearable, like a shirt or a hat or a jacket with that conductive fabric tape on there, and it's great because it's nylon. But it just took a lot of back and forth. And a lot of the things we've done, like tweaks to things that exist already, even our LEDs with built-in resistors, was just working with existing manufacturers saying, hey, can you do this? Is that something possible? I know LEDs with resistors in them had existed for a long time, but you're hard pressed to find any in just general crafting use. I think really only Chibitronics with their circuit stickers really has LEDs for crafting with resistors on them. And they're just little resistors onto their little parts.
Yeah, they're just like separate on the same little sticker.
And our big issue was there's no room on our board here to put a resistor. We want to make sure we had resistors. So we're like, can we get it done with a resistor in the head? And we did. And if you take a multimeter and you check the amperage drop between, say, one of these and just a random LED, much less, you can see that there is the resistor built in there, which we occasionally spot check and do to make sure that our manufacturer is still doing it for us. But yeah, a lot of the stuff is just testing things out, seeing how we like it, playing around with it. And for someone, a small company like us, it's just a lot of trial and error, playing with it, getting some feedback from other people we know, and then also checking with children, because nothing is more fun than a really well engineered project that's only tested by adults, because they miss out on all those kid things like, oh yeah, kids are assuming XYZ, or even just adults who are newbies to the area. They assume something, and if they assume it and it's wrong, you have to really try to account for that. That's why we make so many great directions and projects, thanks to Pete over here, and our great curriculum, thanks to Andy, our curriculum writer, that really handhold people in through those initial steps, because we have to assume that everybody's new. You're walking into this cold off the street. We want to make sure that they have a good time and understand how everything works, just as much as someone like Pete over here, who's been doing this for years and can sit down and make up a project like this randomly. But we just want to make sure that we're making sure there's that confidence building and people are having really a good time, especially students. They're having a good time. They feel that they can accomplish stuff and they want to try out their own stuff. Because if they feel they can do their own things, they'll learn on their own. They'll self find projects and self build things and troubleshoot. It's great when they're like, oh yeah, I can do this. It's easy. Again, why we like Lego, because Lego is like, oh yeah, I can do Lego. I can do tape.
Yeah, it's very empowering.
It's like conductive dough. It's the same thing. No one sits down and says, oh, Play-Doh, that's too difficult, I'm out. So like squishy circuits dough is great because like, oh yeah, everyone knows how to use Play-Doh. It's easy. But anyway, sorry, please continue.
Oh, I was going to ask you about this beautiful thing you have here. Is that a Raspberry Pi Pico?
It is. This is something we're kicking around because we currently use an Arduino Nano on our robotics board, which is our Arduino-based board. And while we like that, we also know that it's been around for 15 years-ish. And we also like to have a lot of test things in our back pocket. Our GitHub repo is full of like random things we tried out. There's a Beagle board up there and a Raspberry Pi wireless up there too, just because we tried it out for why not. And we did this up as a board, like, hey, if you want to switch to this, we have a board ready to go. We know it works and we can kick into manufacturing pretty lickety split. So this is a Raspberry Pi Pico on one of our Lego breakout boards. We've got pin headers on the backside so you can easily plug in sensors and whatnot in there. And this thing is just a fun little demo board that Pete made up that just to make sure everything works well.
I removed some of the pieces.
He did remove it. There are a few pieces that are missing on here.
Oh,
There should be a piece there. Yeah, but
I had another servo too.
another servo. Anyway, this is our test board, but this is one of the parts that we just, oh, look at that. You make them flash more and more with that. Yeah, look at that potentiometer go. I know it's fancy, but because it's a new part, it's pretty inexpensive too. That's what we like about it. It's only $4 retail, Pete.
Yeah, I believe so.
Yeah, it's really cheap. So we're like, well, if we buy them, a couple thousand at a time, it'd be even cheaper. And we just like make sure we have lots of options. As a small business, like we want to make sure we have things we can fall back on. I have backups for all of our manufacturers in case one of them, burns down or something, just so that we don't lose out on our components and parts and we're not, twiddling our thumbs for a few months. But this is just, a test like, it's really easy. And on our GitHub repo, we do have KiCad files and a nice write-up by one of our former PCB designers on how to design your own parts in our system. And so when we got new PCB designers, our other guy retired for a different job, and they used his own old write-up in the KiCad files and examples on how to make that to help design our new boards, like this guy. So it's really easy. I've had a couple teachers randomly design their own board. One used the Adafruit Circuit Playground made a Lego breakout board for that, which was pretty fun. And one made like a microbit cousin. It's a board in Europe that's similar to the microbit, and someone made a breakout board for that using our Lego format.
Like the code bug or something.
Yeah, I totally forget. It was a while ago, but yeah, it was like it looks like the microbit, but like the cousin from the next state over. Very similar format, but use that in our examples we had up of like, okay, this is how it all works. But yeah, having some other options there is really, really, really handy. And seeing people actually using our stuff to make their own stuff up is really great too. And occasionally, like, hey, that's good design. Let me give you a couple tips for stuff, for designing things as well. But the biggest struggle with designing our crazy circuit stuff wasn't making the parts. It was all the testing to find like the right sized holes that were within manufacturing tolerances, so that things are ever so slightly larger, ever so slightly smaller, doesn't screw up our system, but also so that our parts would pressure fit on well. So our holes here are copper plated inside and through, because there's a pressure fit that happens between the Lego stud and the tape and the board itself. So that's what makes a strong connection. You could lay tape over the top, but just doesn't really stay put super well. But there's that nice, like the fine point between like being too loose, being too tight, being easy to get on and off. It's that little like three porridge situation, so to speak. Yeah, but it was like we had so many test files of like, okay, a little bit more, a little bit less. I think we somewhere have a big board of all these different hole sizes, just ever so slightly monumentally like small increases that we could just test things out. And it has to be enough room for the tape to fit in there and have a nice connection without being too tight or too loose. Because most of our stuff, if you pick it up and turn it upside down, our parts shouldn't fall off.
Oh, nice.
But it's still not tough just to wiggle one off really easily, or wiggle one
Especially
back
with
on.
that big LED to grab onto.
Yes, so we used
So
actually we
nice.
just moved over. We used to make little surface mount, like 2x2 size here, surface mount LEDs, but we found that people love the jumbos and didn't really use those little guys. They're much more difficult to get off because they're flat. So we just like, nope, everyone gets an upgrade to this and all of our kits from here on out.
Yeah,
Because
and if you're going for something super tiny, then why use Lego at all?
exactly. Although we did find we have some fun, couple fun projects where if you use like third-party clear bricks from other places like on Amazon, you can make a layer of surface mount LEDs and then bump it up like one plate and then do clear ones on top to do fun floor lighting effects. And we've done that with a video somewhere. Pete used a bunch of neopixels on a board and then put a nice clear piece over the top. So it looks like a funky dance floor from the 70s.
Oh, that sounds
of Lego.
amazing.
But it was like that, the neopixel thing. Oh, was that the one I made with all the neopixels on it?
Yeah.
Oh, I did that.
Yeah.
I did that for a trade show back when they were all prototype parts, but just it's a 6x6 matrix on a board this size of neopixel. Our parts are 2x3, so this size for neopixels. It was a lot of tape cutting. I'm like, no one's going to do this. There's just lots of little tiny pieces of tape. That's what neopixel strips are for. They're really cheap. But we made a dance floor out of it because it looked silly on video and a bunch of little Lego minifigs on top. But
That's awesome.
anywho, long story short, we're always kicking out new stuff. Again, if you want to look at our GitHub repo with all of our files and how to do things up there or on there, you can see a bunch of other things that we just never manufactured, but they should all work just fine. And there you go. Oh yeah, there's just tons and tons and tons of stuff. Oh yeah, there's our KCAD write-up too. If you click on the circuit kits in the top folder up there, that'll take you to all the individual components we've mocked up over the years. You keep scrolling down. There's nice previews.
Oh, look at that.
Oh yeah,
previews.
we organize this stuff really well. So just parts, standard parts, components, different variations on things we tried in the past. Having a really nicely well organized GitHub repo is great when a manufacturer has a question. So we're like, this is how you do it. But there's just a lot of stuff we just try things out, like, hey, how about a CR232 holder with a switch?
Oh my gosh.
What about USB power, which we never use? But
SOIC chips. Ooh.
Yep.
Oh yeah, we actually have a couple of these. I think you sent us the 555 ones.
Yeah, and we actually used that board with there we go, the AT Tiny 85. That's what we use.
Another favorite.
We just tried a bunch of different boards out just for the heck of it to see how we like the feel, we could learn from it. That's an early microbit version we had that we put together for just trying it out. This was like 4 years ago when the microbit was just fairly new. We're like, well, just in case we ever want to do this in the future, we've tried one out. Yeah, so we actually have a nice Raspberry Pi like Zero wireless on a board in our office and no idea what to do with it because all the projects we would do with it don't need a Lego based setup. But no, the stuff we tried out so we could get a feel for things, and we always like to improve when we can and upgrade parts when we can. Our different NeoPixel variations we tried. And the issue with NeoPixel was trying to get all the right parts onto a Lego plate between the stuff. It wasn't until they came out with an even smaller, like a little bit smaller LED. There's the standard size NeoPixel is too big to fit on between the Lego studs. And then when we were working at, they'd started releasing like smaller versions. Like, oh yes, thank goodness, it can fit.
Amazing. So anyway, you're always coming out with new stuff. People can follow you on Twitter. Brown Dog Gadgets.
Please do. Our Twitter feed is just really pictures that Pete posts of projects he's working on or things he's kicking around, like the robot hand. And giveaways. We do giveaways of like maker tape on there for mostly the teachers and librarians. Like here,
this stuff is magic. This maker tape is ridiculous.
Well, copper foil was fine because it was the thing everyone had access to. But whether it's from us or other people have nylon tapes now. It's so much easier to work with. If nothing else, for wearables, making simple, inexpensive wearables, putting that on fabric. I hate seeing teachers doing, especially with younger grade levels, doing conductive sewing with kids because sewing is such a difficult thing. It's a new skill set for a kid, and just being able to do like the same.
Even I have trouble getting conductive sewing to work.
We've done it before. Like we made 3 of the same project. One worked really well. One mostly worked most of the time, and one didn't work at all, and we could not figure out why that one didn't work. And it's the exact same activity 3 times over. We're like, well, we're going to give this away, but we can't give it away. It doesn't work. It just is a layer of difficulty on something. And most of the time when people want to do a wearable for, especially with kids, it's a simple light up thing they can wear. And the fabric tape just cuts the cost down and the time down to like 20% of what it would be otherwise. And we sell conductive sewing things because our circuitry stuff, our crazy circuit stuff actually works really well for sewing. It's big holes you can sew.
It makes so much sense.
Wasn't our intention. It just ended up working out that way. And we actually include conductive thread with a lot of our kits. But in general, tell people like, don't do sewing unless sewing is already a core part of what you're doing. And this is an extension to an existing sewing activity, because nothing is more fun than watching a room full of adults. And I've done this before, fail to thread a needle. Got like 30 adults in a workshop and no one can thread a needle. And you're like, this is my day. This is my workshop I'm running. No one, this is everyone. If sewing was the thing, like here's a sewing workshop. People are like, oh yeah, we can all sew. No, they lied. Maybe they sewed 20 years ago. I don't know. All I know is it's really not fun to watch a bunch of adults fail to thread a needle, even worse when they're kids doing it, because you want to make sure they're having a good time, they're engaged, they're excited, and they're walking away with a finished project. So just do that. Actually, maybe I've got one over here. Yes,
Another thing I love about this maker tape while you're looking for that is that like if you fold it wrong, because it's so strong, you can just pull it straight again and it's not gonna like break or snap. It's so lovely.
You can peel it off the Lego without it snapping. So this is actually one of two different versions. This is the more advanced version that Pete made. You can thread the you can thread this through, right, Pete?
Yeah, you can.
Yeah, the other one's a little more sticky based. But yeah, here's your classic light up bracelet. Add decorations to it. And this takes 5 minutes to make for a kid, and they can decorate it galore for much, much less than buying sewable parts from anybody. I mean, sewable parts are pretty available. Like Spark Fun has a ton, Adafruit has a ton, but they're not cheap, like $1 an LED or at least. So I mean, this is just way easier. And yeah, and you want to make sure the kids are having a good time. So, or even this is my favorite go-to one. This is our battery tester, which we can use maker tape with. And I wish I had a battery here, but I don't. It's okay. But we can do stuff like this because the tape is nice and strong, and you can just clamp a battery in here and it lights up because you have a ton of CR232s randomly on this table. But it's a great little project, and it's easy and simple. Or do what Pete did and make a really nice knife switch, cardboard knife switch. So brass brads, maker tape, and cardboard.
Perfect for the budding mad scientist.
It is. Oh, there we go. But yeah, and Pete even made a gigantic version as well, because why not? Oh.
Wow.
And also really nice push button too. Pete made a nice push button with rubber bands. You push it, boing. But yeah, I love some fun things with cardboard. Again, you can't do this with copper foil, and nothing is copper foil. If you have it, use it. But if don't go back to copper foil. Hey Pete, do you have a fun graphic that shows how we feel about copper foil? Oh yeah. One more time for the kids at home, Pete.
Amazing. Yeah. And like the fabric can flex so many times over, like with that clothespin, you can infinitely basically like squeeze that and unsqueeze it and stuff, where copper tape would just like get all, gunked up.
Also, the last thing I'll say here before I have to go and pick up my small child from daycare is we do a tape loop method. One of the most annoying things about old paper circuits projects, you can always tell. You can tell when people learned you could do this fashion because all the projects changed over. Usually I have to use like a binder clip to make a dog ear in the corner or a paper clip. We have some old projects of ours where we still have that in the directions. But with using the fabric tapes, this is nice and sticky, conductive on both sides and strong. You just put a tape loop down, put your battery on top, and run the tape over the top of it. And now you have a battery holder anywhere, which is really one of those things like, oh yeah, I'm no longer constrained for like folding over corners or making weird like battery holder. There's a direction set from a university I will not mention because I feel bad for them, where they have the kids make literally like a paper battery holder for their battery to go into. And this was published like 6 months ago, about a year ago. And I'm like, what? No, that's so difficult to do. Making this, use this method, or even the dog ear corner over, but making like a little tiny paper battery holder was so much work. And I'm like, that's too much work for me for making like a simple edit project. Why would you do that? And this is just easy peasy, and you can do it on a table.
Well, Josh, that bracelet, I mean, you're not going to get a binder clip on there.
Oh yeah,
just tape down.
It's same thing here. We just got a little tape loop on the bottom and then tape over the top.
Magic.
Magic. It is magic. It's, well, science. But no, it's nice, and it makes things easy. So it's the ease of making simple projects that are creative, because 10 people can make the same bracelet and they can all look different, but the circuitry will all be the same. But the fun's in the artwork, and fun is wearing it around and showing it off, or making a fun, ugly holiday sweater for one-time use. 5 minutes of work for sitting there sewing, and I've done that before for holiday sweaters. One LED on a Rudolph nose, like, I've been doing this for so long. Nope, tape. A little bit of tape. You can peel it off when you're done. Life is good.
Amazing.
Yeah, good times.
Just before we can wrap up, everyone, you can follow, as we said, on Twitter. We'll put the links in the description, branddoggadgets.com. Check out all the I love, of course, you have an owl. Best thing ever. Okay.
So I wrote, a pirate owl.
And you can follow Baron Dodge Gadgets on Hackster as well. And go check out. Oh, look at that. Okay, I'm gonna spend some time on that in just a minute. And thank you so much for joining us, Joshua, and taking
Thanks for
time out
having
of your
us.
incredibly busy schedule.
We
and
appreciate you thinking of us. We really do. And yeah, Pete says goodbye too.
Yay, bye,
Pete's over
Pete.
there. So
Thank you guys so much. Have an awesome one. All right.
oh, I'll
cheers.
say this too. If
Oh.
anyone's still watching, all the directions, all the projects we always show on all of our Facebook, Twitter, Hackster, every project we make is open source. Even the parts we make are open source. So if you like what we're doing and like, I don't want to buy from these guys, they're lame. Our projects and directions are still there. You can still go get your own materials, do these in a different format, whatever. We always make sure all of our resources are out there. Even our curriculum we've written for classroom stuff is always up for free. So any teacher can look through there and browse it and figure out if it's worth their time or not. So we really are about like making sure everyone can access our stuff and evaluate it for themselves before they purchase anything or use existing things they already have.
So pro. Thank you so much. That's so badass.
We try.